A web application framework is a software framework that is designed to support the development of dynamic websites, web applications, web services and web resources. The framework aims to alleviate the overhead associated with common activities performed in web development. For example, many frameworks provide libraries for database access, templating frameworks and session management, and they often promote code reuse. For a comparison of concrete web application frameworks, see Comparison of web application frameworks. History. As the design of the World Wide Web was not inherently dynamic, early hypertext consisted of hand-coded HTML that was published on web servers. Any modifications to published pages needed to be performed by the page's author. To provide a dynamic web page that reflected user inputs, the Common Gateway Interface standard was introduced for interfacing external applications with web servers. CGI could adversely affect server load, though, since each request had to start a separate process. Programmers wanted tighter integration with the web server to enable high-traffic web applications. The Apache HTTP server, for example, supports modules that can extend the web server with arbitrary code executions or forward specific requests to a web server that can handle dynamic content. Some web servers were specifically designed to handle dynamic content by executing code written in some languages, such as Java. Around the same time, full integrated server language development environments first emerged, such as Webbase, and new languages specifically for use in the web started to emerge, such as Cold Fusion, PHP and active server pages. While the vast majority of languages available to programmers to use in creating dynamic web pages have libraries to help with common tasks, web applications often require specific libraries that are useful in web applications, such as creating HTML. Eventually, mature, full-stack frameworks appeared that often gathered multiple libraries useful for web development into a single cohesive software stack for web developers to use. Examples of this include ASP.NET, Java EE, WebObjects, Web2py, OpenACS, Catalyst, Modulicious, Ruby on Rails, Grails, Django, Zend Framework, YE, Cake PHP and Symfony. Types of framework architectures. Most web application frameworks are based on the Modeler Euro Viewer Euro Controller pattern. Modeler Euro Viewer Euro Controller. Many frameworks follow the MVC architectural pattern to separate the data model with business rules from the user interface. This is generally considered a good practice as it modularizes code, promotes code reuse, and allows multiple interfaces to be applied. In web applications, this permits different views to be presented, such as web pages for humans, and web service interfaces for remote applications. Push-based versus pull-based. Most MVC frameworks follow a push-based architecture, also called action-based. These frameworks use actions that do the required processing, and then push the data to the view layer to render the results. Struts, Django, Ruby on Rails, Symfony, YE, Spring MVC, Stripes, Play, CodeIgniter and Struts2 are good examples of this architecture. An alternative to this is pull-based architecture, sometimes also called component-based. These frameworks start with the view layer, which can then pull results from multiple controllers as needed. In this architecture, multiple controllers can be involved with a single view. Lift, Tapestry, JBoss Seam, Java Server Faces, Micro, and Wicket are examples of pull-based architectures. Three-tier organization. In three-tier organization, applications are structured around three physical tiers: client, application, and database. The database is normally an RDBMS. The application contains the business logic, running on a server and communicates with the client using HTTP. The client, on web applications, is a web browser that runs HTML generated by the application layer. The term should not be confused with MVC, where, unlike in three-tier architecture, it is considered a good practice to keep business logic away from the controller, the middle layer. Framework applications. Frameworks are built to support the construction of Internet applications based on a single programming language, ranging in focus from general-purpose tools such as Zend Framework and Ruby on Rails, which augment the capabilities of a specific language, to native language programmable packages built around a specific user application, such as content management systems, some mobile development tools and some portal tools. General-purpose website frameworks, for example, Zend Framework. Discussion forums, wikis and weblogs, for example, Wikibase WikiWeb. Organizational portals, for example, JBoss Portal or EXO Platform. Content management systems. In web application frameworks, content management is the way of organizing, categorizing, and structuring the information resources like text, images, documents, audio and video files so that they can be stored, published, and edited with ease and flexibility. A content management system is used to collect, manage, and publish content, storing it either as components or whole documents, while maintaining dynamic links between components. Some projects that have historically been termed content management systems have begun to take on the roles of higher-layer web application frameworks. For instance, Drupal structure provides a minimal core whose function is extended through modules that provide functions generally associated with web application frameworks. The Solidov and Joomla platforms provide a set of APIs to build web and command line applications. However, it is debatable whether management of content is the primary value of such systems, especially when some, like Silverstripe, provide an object-oriented MVC framework. Add-on modules now enable these systems to function as full-fledged applications beyond the scope of content management. They may provide functional APIs, functional frameworks, coding standards, and many of the functions traditionally associated with web application frameworks. Features: Web Template System. Caching. Web caching is the caching of web documents in order to reduce bandwidth usage, server load, and perceived lag. A web cache stores copies of documents passing through it. Subsequent requests may be satisfied from the cache if certain conditions are met. Some application frameworks provide mechanisms for caching documents and bypassing various stages of the page's preparation, such as database access or template interpretation. Security. Some web application frameworks come with authentication and authorization frameworks that enable the web server to identify the users of the application, and restrict access to functions based on some defined criteria. Drupal is one example that provides role-based access to pages, and provides a web-based interface for creating users and assigning them roles. Database access, mapping and configuration. Many web application frameworks create a unified API to a database backend, enabling web applications to work with a variety of databases with no code changes, and allowing programmers to work with higher-level concepts. For higher performance, database connections should be pooled as for example OWL Server does. Additionally, some object-oriented frameworks contain mapping tools to provide object relational mapping, which maps objects to tuples. Some frameworks minimize web application configuration through the use of introspection and/or following well-known conventions. For example, many Java frameworks use Hibernate as a persistence layer, which can generate a database schema at runtime capable of persisting the necessary information. This allows the application designer to design business objects without needing to explicitly define a database schema. Frameworks such as Ruby on Rails can also work in reverse. That is, define properties of model objects at runtime based on a database schema. Other features web application frameworks may provide include transactional support and database migration tools. Scaffolding. URL mapping. A framework's URL mapping facility is the mechanism by which the framework interprets URLs. Some frameworks, such as Drupal and Django, match the provided URL against predetermined patterns using regular expressions, while some others use URL rewriting to translate the provided URL into one that the underlying engine will recognize. Another technique is that of graph traversal, such as used by Zope, where a URL is decomposed in steps that traverse an object graph. A URL mapping system that uses pattern matching or URL rewriting allows more friendly URLs to be used, increasing the simplicity of the site and allowing for better indexing by search engines. For example, a URL that ends with /page cat equals science and topic equals physics could be changed to simply science physics. This makes the URL easier for people to read and handwrite, and provides search engines with better information about the structural layout of the site. A graph traversal approach also tends to result in the creation of friendly URLs. A shorter URL such as science tends to exist by default, as that is simply a shorter form of the longer traversal to science physics. AJAX. AJAX, shorthand for asynchronous JavaScript and XML, is a web development technique for creating web applications. The intent is to make web pages feel more responsive by exchanging small amounts of data with the server behind the scenes, so that the entire web page does not have to be reloaded each time the user requests a change. This is intended to increase a web page's interactivity, speed, and usability. Due to the complexity of AJAX programming in JavaScript, there are numerous AJAX frameworks that exclusively deal with AJAX support. Some AJAX frameworks are even embedded as a part of larger frameworks. For example, the jQuery JavaScript library is included in Ruby on Rails. With the increased interest in developing Web 2.0 rich media applications, the complexity of programming directly in AJAX and JavaScript has become so apparent that compiler technology has stepped in, to allow developers to code in high-level languages such as Java, Python and Ruby. The first of these compilers was Morphic, followed by Google Web Toolkit, with ports to Python and Ruby in the form of Pajamas and Ruby.js following some time after. These compilers and their associated widget set libraries make the development of rich media AJAX applications much more akin to that of developing desktop applications. Web services. Some frameworks provide tools for creating and providing web services. These utilities may offer similar tools as the rest of the web application. Web resources. A number of newer Web 2.0 RESTful frameworks are now providing resource-oriented architecture infrastructure for building collections of resources in a sort of semantic web ontology, based on concepts from Resource Description Framework. See also, Comparison of Web Application Frameworks, Rich Internet Application, List of Rich Internet Application Frameworks, List of Web Service Frameworks, Comparison of Application Servers, Application Framework, Application Security, Convention over Configuration, Don't Repeat Yourself, Solution Stack, Multiple Phone Web-Based Application Framework, References.